Infinity. It's not just a number. It's a riddle, a whisper from the edge of understanding. Picture this. You're walking down a path that never ends. There's no wall, no border, not even a horizon. The more you walk, the more the path stretches. It bends around thought, loops behind reason, and slips just out of reach. That feeling, that's infinity. But pause for a second. What are we even talking about? Is infinity an actual thing or just a word? A placeholder for the unknown? Is it the endless size of the universe, a never-ending timeline, or just something the human mind invented because it couldn't handle limits? You see, we toss the word infinity around like it's nothing. We say time is infinite, space is infinite, even possibilities, infinite. But what is infinity? To a physicist, it might be an unsolvable glitch in an equation. To a mathematician, it's a symbol. To a philosopher, it's the cliff edge of human thought. And yet, the strange part is, we feel it. Deep down, we somehow sense the presence of the infinite. Maybe it's in the night sky. Maybe in the silence between seconds. Or maybe in that strange quiet thought that creeps in at 3 in the morning. What if there's no end to anything? This video is about that question, not just what is infinity, but why does it haunt us? Why do we keep returning to it? And perhaps most importantly, could the existence of infinity be the clearest sign that something greater lies beyond this physical world? Let's begin. Long before telescopes, particle colliders, or quantum equations, there were just people sitting under the stars, watching the sun rise and fall, counting the waves, wondering where it all ends, or if it ever does. The ancient Greeks were some of the first to wrestle with the idea of the infinite, but they didn't all agree on what it meant, or whether it was even real. Take Aristotle, for example, brilliant, precise, and grounded in logic. He didn't like the idea of actual infinity. To him, infinity was potential. Not something that existed in reality, but something that could go on indefinitely if you allowed it to. Like numbers, you can keep counting forever, but you'll never reach an infinite number. It's always just the next one, and the next, and the next. Aristotle saw infinity as something uncomfortable, a paradox, a thing the mind could grasp but never hold. But not everyone agreed. Enter Zeno of Elea, the master of paradoxes. He asked, if you want to walk across a room, you first have to get halfway. But before you get halfway, you have to get a quarter of the way. And before that, an eighth, a 16th, a 32nd. So if there are infinite steps between you and the other side of the room, how do you ever get there? This wasn't just a game. Zeno was pointing at something deeper. That space, time and movement itself might be illusions. That the infinite isn't just a number, it's a crack in the very structure of reality. And while many tried to solve Zeno's paradoxes with clever math or modern physics, the real power of his ideas still lingers. Not because they confused people, but because they made something familiar feel impossible. Infinity was no longer a distant idea. It was something hiding in plain sight, in every step, every second, every line you draw. And behind that unsettling thought was an even deeper question. If there are infinite divisions in space and time, then who or what holds it all together? Maybe reality isn't just built from atoms and forces, but from something else entirely, a design, a logic, a mind. For most people, mathematics is about certainty, equations, proofs, answers, but then infinity walks into the room, and everything starts to tremble. No one felt this tremble more than a man named Georg Cantor. In the late 1800s, Cantor did something outrageous. He measured infinity. You see, most people thought infinity was just one thing, big, endless, that's it. But Cantor, he discovered that some infinities are bigger than others. It sounds impossible, doesn't it? Infinity is infinite. How can one be more infinite than another? Here's how he explained it. Take the set of all natural numbers, 1, 2, 3, 4, and so on. That's infinite. Now take the set of all real numbers between 0 and 1, decimals like 0.1, 0.2456, 0.9999 repeating forever. Also infinite. But when Cantor compared the two, he showed something shocking. There are more real numbers between 0 and 1 than there are whole numbers in the entire universe. This wasn't just a math trick, it was a revelation. Infinity had layers, it had a hierarchy. Cantor gave them names: 0, Aleph Null, for the smallest infinity, and then larger and larger ones, reaching into a realm beyond comprehension. And for this, he was attacked. Not just by critics, but by the very heart of the mathematical community. They called him reckless, heretical, some even called him mad. But Cantor stood by his discovery, because in those infinite sets he believed he had seen something more, something divine. In fact, Cantor once wrote, "The essence of mathematics lies entirely in its freedom." And in a private letter, he confessed that he believed his theory of infinity was whispered to him by God. Was he right, or just a man overwhelmed by the abyss he helped reveal? Whatever the answer, one thing was clear. Infinity wasn't a number, it was a mystery, one that lived at the edge of logic, and perhaps at the threshold of creation. Let's leave the chalkboards of mathematics and walk into the cold, glowing corridors of physics, where equations don't just describe ideas, they describe reality. And here too, infinity lurks, not as a concept but as a problem. Take black holes. According to Einstein's equations, at the center of a black hole lies a singularity, a point of zero volume and infinite density, infinite gravity, infinite curvature of space-time. It's the kind of result that makes physicists uncomfortable. Not because they dislike big numbers, but because infinity in physics often means we don't know what's going on. It's not just black holes. At the very birth of the universe, the Big Bang, we're told everything came from a single infinitely dense point. Time began there, space began there, everything. But again, that word, infinite, when physicists see it in an equation, it's like hitting a wall. It doesn't say, here's the answer. It says, here the laws break down. In quantum mechanics too, infinities arise when calculating energy levels, when probing the vacuum of space. In the 1940s, physicists tried to make sense of it all with a technique called renormalization. They would cancel out the infinities by subtracting other infinities. Even the great Richard Feynman, one of quantum theory's heroes, admitted it felt like cheating. He called it a dippy process, even though it gave accurate predictions. So what is going on here? Why does infinity keep showing up, and not as a triumph, but as a crisis? Maybe the universe isn't truly infinite. Maybe we're using the wrong tools, or maybe we're seeing signs of a deeper architecture, a structure that isn't fully visible from within the universe itself. Like a two-dimensional being trying to comprehend a three-dimensional world. Maybe we hit the wall of infinity, not because it's an end point, but because it's a veil between what we can explain and what we're meant to seek. Now let's ask something deeper, something more human. What does infinity mean for time? Is the universe moving forward toward an end? Or is time itself a loop? The ancient Greeks spoke of the eternal return, the idea that time isn't a line but a circle, that everything repeats over and over forever. The philosopher Nietzsche famously imagined this. What if, he asked, you had to live your life again endlessly, exactly the same each time? Would you embrace it or collapse under the weight of it? But today, physics has its own take. Some cosmological models, like conformal cyclic cosmology proposed by Sir Roger Penrose, suggest that the universe might go through infinite cycles of big bangs and big crunches, an endless series of eons, each one birthing a new cosmos, each one leaving faint imprints in the microwave background of the next. If that's true, then we're not just in a moment of time. We're in a pattern, a rhythm, a cosmic heartbeat that never stops. Other theories go even further. In quantum mechanics, there are interpretations that suggest all possible events, every choice, every outcome exists simultaneously across an infinite multiverse. That every time you decide whether to speak or stay silent, you create a split, a new branch. And in that view, you are infinite too. Not just once, not just now, but always. It's poetic, it's terrifying, and it forces a question we can't shake. If time loops forever, if there are infinite versions of us, infinite lives, infinite cosmoses, then what is the point of anything? Why choose? Why care? But maybe that's exactly why the idea matters. Because when faced with the infinite, every finite act becomes sacred. Every breath, every moment of love, every small decision to be kind or brave or curious. In a world without end, it is your will that gives meaning. Let's step into the strangest part of this journey, the place where logic itself begins to fall apart. Infinity isn't just a huge number, it's not a lot. It's something much weirder. Think about this. Infinity plus 1 is still infinity. Add a million, still infinity. Even infinity plus infinity doesn't change anything. It's like pouring more water into an ocean that never gets full. No matter how much you add, it stays the same. But now comes the twist. There are just as many even numbers, like 2, 4, 6, as there are total numbers, 1, 2, 3, 4. How can that be? How can part of something be the same size as the whole? This isn't a trick, it's a real concept. It's called Hilbert's Hotel, a famous thought experiment by the mathematician David Hilbert. Imagine a hotel with an infinite number of rooms, all of them full. Then someone new shows up, no problem. Move the guest in room 1 to room 2 to room 3, and so on. Now room 1 is free, infinite space, but always more room, and it gets even stranger. Some infinities are bigger than others. For example, the infinity of real numbers, like all the tiny decimals between 0 and 1, is bigger than the infinity of whole numbers. This was proven by mathematician Cantor. His ideas changed math forever. But they came at a cost. He struggled with mental health, felt isolated. Some say he was haunted by the very infinities he discovered. Because once you truly face infinity, something changes. You realize our minds, our language, even our logic, they're not made to handle it. Infinity doesn't follow the rules, it breaks them. And yet, it's everywhere in science, in motion, in time, in equations. We use it in calculus and physics every day. But here's the real question. Does infinity actually exist in reality? Is space infinite? Is time? Is God? Or is infinity just an idea, a shadow of something beyond us? And if so, where did that idea come from? Why can the human mind even imagine infinity, when nothing in our experience is truly infinite? Maybe it didn't come from us at all. Maybe it was placed in us, a clue, a whisper, a reminder of something beyond logic, beyond the finite. Infinity isn't just a philosophical curiosity, it's sitting at the heart of our most powerful scientific theories. Take calculus. Without infinity, there's no way to measure motion, no way to describe how things accelerate or how forces act at every moment. We use limits, values that get closer and closer forever, to describe how things behave in time and space. Even Einstein's equations curve around the idea of infinity. But here's the twist. Sometimes infinity doesn't help, it breaks everything. Physicists call them singularities, points where the math just explodes, where equations give answers like infinite density or infinite energy. Sound familiar? Black holes, the Big Bang. At their cores, we hit the same wall. Infinity. But infinity in physics is a warning sign, a signal that our theories might be incomplete. When we see infinity in an equation, it often means we don't really know what's going on here. It's not just a number. It's a problem. This is why physicists are desperate to find a theory of everything, a way to unite general relativity with quantum mechanics. Because right now, at the smallest scales and the largest scales, our best theories clash. One says smooth curves, the other says discrete particles, and between them, infinity sits like a fault line. Some hope string theory might solve it, others look to loop quantum gravity or even new dimensions. But no matter what, they all circle the same question: is infinity real, or just a placeholder for something we don't yet understand? And here's the deeper thought: if infinity keeps showing up, in math, in physics, in our minds, then maybe it's not a mistake, maybe it's a message, a reminder that there are places reason alone can't go, that behind the elegance of physics lies something even more mysterious, something infinite. So now we come to the edge of numbers, the edge of logic, the edge of what the human mind can even begin to hold. Infinity isn't just a mathematical oddity, it's a mirror. When we talk about infinity, we're really talking about ourselves, about the way we long for something more, something that never ends, something that lies beyond every limit. Why is the mind of a finite creature so obsessed with the idea of the infinite? Why can we even conceive of a thing we can never fully grasp? It's as if infinity is pulling us, calling us, not just to understand, but to remember that we are more than flesh and neurons, that buried deep within us is a hunger for truth that never runs out, for beauty that never fades, for love that never dies. Infinity lives in our questions, in our awe, in the way we look up at the stars and whisper, there must be more than this. And maybe there is. Because the greatest minds in history, from ancient philosophers to modern physicists, have all at some point stood in silence before the infinite. And in that silence, some have heard God, not in thunder or fire, but in the whisper of a number that never ends. So maybe infinity isn't just a concept, maybe it's a clue, a fingerprint of something, or someone beyond space, beyond time, beyond all we know. And maybe the fact that we can feel that truth, even if we can't explain it, is the clearest sign that we were made for it, made for wonder, made for mystery, made for the infinite. So the next time you think about infinity, don't just think about numbers, think about yourself. Because maybe, just maybe, you were never meant to end. If this journey made you think, don't forget to subscribe. There's so much more to explore together.